The image on the right shows a toy which uses a series of cams and inline flat followers to create a linear vertical movement. Draw a displacement diagram for a similar cam mechanism which will impart the following motion to an inline follower given the following data. 0 to 60 degrees, rise of 90 millimeters at uniform velocity. 60 to 90 degrees at dwell. 90 to 270, fall of 60 millimeters with uniform acceleration and retardation. 270 degrees to 360 degrees, return to initial position with uniform velocity. Note, it is not necessary to draw the cam profile. In the displacement diagram, use a distance of 15 millimeters to represent each 30 degree interval. Okay, so the information we'll take from that. We have a rise of 90 millimeters. So the height of our diagram is going to be 90 millimeters. It also tells us here use a distance of 15 millimeters to represent each 30 degree interval. Okay, so each section of 30 degrees, so we're going from 0 right up to 360, will have a 15 millimeter interval. We need a rise of uniform velocity, a dwell, a fall of 60 millimeters. So we started with 90 and we're going to fall down 60. Okay, that's important to note because we're not falling to the very bottom. Of uniform acceleration and retardation, and a return to initial position with uniform velocity. Okay, we'll answer that in a minute. We'll read part B before we answer part A. So the image on the right shows a modern penny farthing bicycle. The front wheel has a radius of 350 millimeters. The wheel is shown in a line diagram format in figure C4b below. The spokes are 30 degree intervals. A reflector as shown is located on one of the spokes at a height of 220 millimeters above the ground. The wheel rolls along the horizontal line AB. Plot the locus for the reflector for one full clockwise revolution of the wheel. Okay, so scale 1 is to 10. So that's important to note because these are all in millimeters, so we need to divide them by 10. So 350 will be 35 millimeters, 220 will be 22 millimeters. Okay, so what's important to note here is we know that our center line for the wheel is going to be 35 off the ground line, and this is the position of the reflector. Okay, they're important to note. You'll see that when I'm answering the question. So we're going to tackle this question. Right. So the first thing we need to do is we need to draw a displacement diagram. So we're told it's 90 millimeters high, and there's a separation of 15 millimeters between each 30 degree interval. Okay, so I'm going to start it roughly halfway across my page. I'm going to come up 90 here, and I'm going to draw a line across any distance. Get my compass, set that to 15. Okay, so count out each set of degrees. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330 and 360. Okay, so that's all my inputs. Alright, again I have to come up 90 on this side. Okay, so I'm going to zoom in about small for you. Now, so again, I'm going to divide up all this section. Okay, so 0 degrees, 30, 60, 90, 120. Make sure you write these on them, okay, because it can get confusing and you need to show the examiner you're doing it. Okay. So it tells us for the first 60 degrees, it's a 90 degree, 90 millimeter rise with uniform velocity. Okay, so from 0 to 60, it's just going to be a direct rise. Okay, it tells us from 60 to 90, there's going to be a dwell. So a dwell is going to be straight across. And then from 90 to 270, there's going to be a 60 millimeter fall with uniform velocity. Okay, so 60 millimeter fall. 60 millimeter fall will be here. From 90 to 270, so 150, 270 is here. Okay, so this I'm going to divide up like my parabola. Now because it's 60, I can just divide it up in 10 millimeter intervals. Okay, so connect my first one back to 90. So it crosses here. It's going to be my first point. Second one here. Third one is going to be right on that point, and it's going to be the same for here. Okay, so I can fit in my curve. Okay, and then my last one is a return to initial position with uniform velocity. Okay, so that's just going to be straight down to 0. We started at 0, so we start at 0. Okay, so 0 being here, 90 being up here. Okay, that's part A of the question done. Okay, so part B is with my petty farthing wheel. Okay, I want to zoom out now, smaller feet. Okay, so again, we need our compass for this, and we're told that it's a scale of 1 is to 10. So the first thing we're told is the size of the wheel is 350 millimeters, so 350 divided by 10 is 35 millimeters. We need to get that on our compass. I'm going to draw my wheel somewhere here on the left hand side. I'm going to move this over the side so you can see it a bit better. Okay, so I'm going to throw my wheel here. Now, the two lines I need for this is first I need my ground line, and then I need my centre line. Okay. Now, when I've that done, I can divide up my circle in 30 degree intervals. It tells me this in the question. Now, I'll just do these a bit heavier because you might be able to see them. Now it tells me then that my spoke, or my reflector, sorry, is, I know, is 22 millimeters. Okay, so I'm gonna, from the ground I'm gonna come 22, and it's on this spoke here, so 22, give me that mark there. Okay, just give a little X on the page. Now, the next thing I need to do is I need to give each of these a number, because each of these it's going to roll, it's rolling in a clockwise direction, so each of these is going to come down onto the ground. Each of these spokes, we'll call them, is going to come down onto the ground. So for example, the first one to come down is going to be this one here, so I'm going to give that number 1, call this number 2, number 3, number 4, 5, 6, 7, 8, 9, 10, and 12. Back to our start. Okay, now what I need to do next is I need to get the distance between each of them. So the distance between all of them is going to be the exact same because they're at 30 degree intervals. So I just have to get the distance between, let's say, 12 and 1 there. I mark off that distance. So that's where 1 is going to be. That's where 2 is going to be. And I mark them all across till I get to number 12. Okay, again, mark all these. Just makes it easier to follow. Now, I'm going to follow these lines up to my centre line. And you'll see why I'm going to do that. I'll explain why I'm going to do that in a minute. Okay. So what we're going to be doing is we're going to be plotting the path of this reflector as the wheel rotates. So to do that, we're going to need 2 points. I'll show you those 2 points now in a sec. Now, our first point is going to be from the center of the wheel to the reflector. That's never going to change. So, for example, I could actually draw an arc around the whole wheel where the reflector is, if I wanted. That shows me that the distance doesn't change from the center of the wheel to the reflector. The next distance is from each spoke to the reflector. So, for example, my first one is going to be from number 1 to the reflector. My next one is going to be number 2 to the reflector. Okay, does that make sense? So it's never going to change. That's the distance that's going to change, whereas the one from the center is always going to stay the same. Okay, so we'll do the first. So I'm going to go to number 1, and I'm going to go right to the position of the reflector. I bring it down to my number 1 when number 1 is on the ground, and I'm going to draw an arc for that. Okay. Now I don't know where it's going to hit yet, so I draw it anywhere. I kind of know it's going to be somewhere here, so that's where I'm drawing it there. Get the distance then from my reflector to the center. I'm going to go to the center of number 1. You can see that there. I'm going to mark off an arc. So that's my first point. The next one, I'm going to go to number 2 and my reflector then. And I'm going to go to 2 on the ground. And I'm going to draw my arc. Again, I'm going to go to my center and to the reflector, and I'm going to go to my center of number 2, and I'm going to mark off my arc. Same process for number 3. So I go to number 3 on the wheel, bring it to the reflector, number 3 when it hits the ground, and I draw my arc. Center of the wheel, back to the reflector. Now if you had 2 compasses for this, it would be awful handy. It's going to be there. And I do the same process for every step. Okay, so you just see me doing that now for every step. Okay, I'm just going to mark that one a bit clearer because it won't be a bit confusing. Sorry. Over that one again. Okay, so you can see a rough guide of the path there. When you have that done, you need to fill it in. Okay, so I suppose it's going to come. Move around. The distance between each individual spoke is different. So you need to get each individual one, so you go around 1, 2, 3, 4 and so on, and the distance between the center and the spoke or the center and the reflector is always going to remain the same. Okay, hope this helps.